Ooh, I don't have an intro. Oops. Super volcano bad? Oh, people are going to have to hear me type. I hate to do this.
Sorry, people. I'm leaning away from my mic to drink, though.
Ew, yeah, because it's so gross. Yeah.
I have learned this.
Yeah. Yeah. There's no cool way to do it on a podcast. If you're going to make a podcast and you're going to slurp a coffee on the podcast and you think you're being cool, like you're somehow...
No.
You're not. You're just making a audio horror show for anyone who's listening. Don't do it.
Yeah.
I'm going to make a whole bunch of sounds here. Let me see. I guess I could. Here, let me. I can't mute this one.
Chair.
Oh well.
So Nancy is reminding everyone out there watching live, so we're not going to put this in our recording. We are doing usability testing of CosmoQuest next week, where we're going to ask folks like you guys out there to go through our website and help us figure out how we can make it better, what we're doing right, what we're doing wrong. We have one set of opinions that may not be the right set of opinions on how to set up things like navigation. So if you're interested in being one of the people that helps us set up our website, go ahead, reach out to Nancy. She's putting all the information in both the YouTube chat and the Weekly Space Hangout crew chat. And we are giving giving Amazon gift cards to everyone except for the dog, who is willing to give their opinions on the website in a Nancy-defined, set way. We're working with Interface Guru, which is a company down in Tucson, Arizona, women, minority-owned, and so spread the love.
What does your T-shirt say? Asks the chat.
It says... Here, let me see if I can get it on camera.
Not that I'm so smart. It's just that I stay with problems longer. It's not that I'm so smart. It's just that I stay with problems longer.
Yep.
It's funny. I did a live stream last week because we didn't do Astronomy Cast, and so I just went over to Instagram and did a live stream there. Mm-hmm. And I got a question from a bunch of people. I've seen this question a few times where someone goes like, I really want to get into astronomy and physics, but I'm really bad at math. And that's okay. It's okay, right? Like, are you great at math? Native? No.
And for those of you who don't try and read my Twitter feed, I am honest to God dyslexic, like the learning disabled kind, where I was given a choice in high school. I could either go to the resource room or take honors classes, because apparently in the 80s you were only allowed to be one or the other. But yeah, I had the weirdest standardized tests growing up because like dyslexia is real. Yeah. And yet I have a PhD in astrophysics because there's multiple ways to contribute to science.
And so it's like, if you think you're bad at mathematics, you're not. What you really are is someone who hasn't spent enough time practicing the things that you just aren't good at. So you need to I practice with my kids, right? Which is like, identify specifically the things that you don't think that you're good at, separate them, right? Isolate them, and then figure out a way to practice that one exact thing. If you're having trouble with something in calculus or Fourier transformations or three-dimensional, I'm just gibberish now. Just like take that one thing and then do 100 questions of it, because as a working astronomer, you just use the same math again and again and again and again. Once you've learned it, it's just a tool that you bring out. It's a hammer.
Well, and the other thing is you just find tools. One of the things that in graduate school I realized was my undergraduate education hadn't included Mathematica or MATLAB. And so the students that were in my classes with me that knew how to do Mathematica, they could type in the equations we were trying to solve, and the software did magic.
Yeah.
And so they had a different skill that allowed them to overcome difficulties. And admittedly, learning Mathematica takes as long as learning certain aspects of calculus, and it's just a matter of where do you thrive.
Yeah. And that's it. And I think that if you love this stuff, but you think that that you're not good at it, you're so wrong. And I really wish that you just sit down and just take the time, just practice, and you'll get it. So, if you think that math is the thing that's holding you back, it's hilarious.
And you don't have to like it. This is something I tell students when I teach E&M. There's a special dark spot in my heart for solving for the current through a resistor. It is something I despise doing. Can I do it? Yes. Do I enjoy myself? No. Yeah. Forever and always, circuit diagrams will look like dead squashed bugs. But I can do it. So at a certain point, it's just learning the skills you're required to have and persevering.
Yeah. Hey, Nancy, how should people contact you when I give you a free advertisement in Astronomy Cast? So should they send you an email to your email address?
Email cosmoquestx@gmail.com.
No. Nancy Graziano. I'm going to give Nancy Graziano a gigantic shout out in the intro of Astronomy Cast to help her get some work. And so she needs to tell me how she wants to receive. Like, do you want it sent by email? Let me know. So if you have no idea what it is that you've stumbled into, this is going to be a live episode of Astronomy Cast. We are going to record part 4 of our Destroy and Rebuild series, where we talk about supervolcanoes. And I prepared Pamela before this episode went on to remind her, as enthusiastic as she gets about the scale and devastation of a supervolcano, there will be a lot of human suffering caused by them. So, we need to just balance that. That's all I'm saying. To just remember, like a pandemic, like a robot uprising, like an asteroid strike, as cool as these things are, hypothetically, theoretically, they would be the cause of tremendous human suffering. So, just keep that in mind. You're saying you lost my audio.
I can hear you, but I'm on a different system.
I don't know what to say. This is the different microphone. What now? Huh? Your move, YouTube viewers.
And Francesco, it's okay to knit and study electronic circuit boards and all of the above. My knitting is on the windowsill behind me.
Okay. I'm going to say hi to a bunch of people. To Daniel McCool, Francisco Alves, H. Roll, John Suffield, Kyla Shretha, Lillian Brandon, Michael Jobin, Ole Jorgen Nordhagen, Paul Disney, Paul Gracie, Sergio Patero, Tech Tang, Toby Samples, Tom Van Scotter, William Hutchins. And remember, stick around after the show and we will answer your questions about space and astronomy or catastrophic nightmare devastation at a horrific scale. Okay.
Yay!
Yay! All right. Here we go.
Pressing record, I'm taking.
Would you be so kind? I've also pressed
Yeah, I'm
record.
okay. We were recording. Hi, Chad.
Hello, Chad. Here we go. Astronomy Cast, episode 440, Supervolcanoes. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. It's so smooth. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
I'm doing great. So I've got sort of two pieces of administrivia. So the first thing is that our good friend Nancy Graziano, one of the sort of heads of the Weekly Space Hangout crew, is looking for work. She is a talented technical writer and one of the most just skilled human beings that I know of, and has sort of, popped out of the woodwork and made herself instantly super important to the whole, all of the projects that we work on as a volunteer, and you really need to hire her to get her a job. So just send her an email if you've got technical writing work, or like a position as a technical writer somewhere in the United States. Nancy.graziano@gmail.com. Let her know you've got work for her. Okay.
And both of us will write a rec letters.
Yeah,
this is from both of us.
Yeah, but if you are like in some firm, Google anyone, and you want to, you're looking for like a really skilled, both human being and technical writer, Nancy's your person. The second thing is I just want to, remind, this is sort of the third time I guess I've made this joke now, but just to remind everyone that no matter how enthusiastic Pamela gets about the concept of supervolcanoes, she does recognize and understand that they're the cause of tremendous human suffering. So please remember that as you hear her enthusiasm, just don't think that she's a horrible soulless monster. All right, let's get on. So there are regular volcanoes, and then there are supervolcanoes, massive calderas of hot magma of incomprehensible size. Bad news: these things explode randomly and catastrophically. Worse news: there's a bunch around the Earth. All right, so tell us the difference between a regular plain old volcano and a supervolcano.
It basically comes down to size matters if you're a volcano. They break volcanoes up into their volcanic explosivity index. So how much of a mess, a disaster, a world-changing event can one of these things cause? And supervolcanoes are generally considered to be those volcanoes that have a VEI, volcanic explosivity index, of 7 or 8. And I'll back that up and put numbers on
Please
that.
do.
So a 6, which is not a supervolcano, we know what these look like because we had Krakatoa go off in 1883. We have written records of that. We had Pinatubo go off in 1991. These were category 6, and this is a logarithmic scale.
Right.
So these are things that produced 10 and 25 cubic kilometers of magma coming out of them and coating the landscape. Logarithmic scale. So it's the level 7s and 8s that are the supervolcanoes. So here we're looking at things that have like 10 to the 15 kilograms of ejecta coming out of them. They are
they measure it in
spewing
cubic
out
kilometers, right?
Yeah, so it's 100 cubic kilometers to over 1,000 cubic kilometers for these things. So let's think about that. That like, this is how you make new mountain ranges. So the Siberian traps, this is where we've had this kind of an outlaying of magma in the past. Just let's change the whole landscape with lava. Why not?
Right. And so, you mentioned the Siberian traps. I don't know why they call it the Siberian traps, but because there's like
the word
traps.
traps.
Deccan traps as well, right?
Well, and they're
the same
both
thing?
actually, and they're both using a Swedish word. I don't know why it's a Swedish word, but the word means stairs. And when you look at them, because lava coming out in different epochs ends up forming bottom layer, next layer, they kind of look like stairs. And so the Siberian traps, Siberian stairs, this is where we have millions of cubic kilometers of, or sorry, square kilometers of area covered in lava.
Right. Okay. So you've got, like a regular volcano. Maybe they have a few cubic kilometers, like the Krakatoa, like the Pinatubo, a few cubic kilometers. When you get up into the supervolcano, then you have potentially hundreds or thousands of cubic kilometers of material that gets ejected all in one go. What does the caldera, what does it look like geographically? If you could sort of slice the Earth in half and take a look inside, when you're looking at a supervolcano, what are you seeing?
So different supervolcanoes, it's again a descriptor of how much stuff is going to come out when this chamber of magma blows. And so geographically, they can have multiple sources, just like volcanoes have two different sources. So in general, when we're looking at volcanoes, we have hotspot volcanoes like the Hawaiian Islands that are caused by magma plumes welling up. And as the crust moves over one of these magma plumes, the magma drills through the crust of the Earth and spews out the surface, creating new islands.
Right.
Now, Yellowstone, supervolcano, super caldera, is one of these hot spots. And it's actually, of the lists of massive eruptions known through history, it is the cause of the largest number of gigantic eruptions of all of the massive volcanoes. It has, in fact, had 6 magnitude 7 and 8 volcanic eruptions. This is a hot spot under the crust of the Earth with a magma plume that just keeps filling up a chamber with increased more and more pressure, tilting lakes so that they flow across the surface of the planet.
Yeah.
And
right,
when
okay.
it blows, it just, yeah.
So give us a sense of the devastation, right? So in Yellowstone, this gigantic caldera, hundreds, thousands of cubic kilometers of magma ready to explode. What kind of an impact if such a volcano was to go off?
So I found this awesome diagram of notable volcanic eruptions, and some of the ones that it shows for past Yellowstone eruptions have the impact zone for where there was serious destruction on the surface of the planet, essentially spanning from the Mississippi River, where I am at the border between Illinois and Missouri, all the way out to the coast of California. So we're looking at pretty much all of the Great Plains, the Rocky Mountain regions, California. It looks like it ends right around Vancouver. So yeah, we're talking massive amounts.
And are you saying that there are
destruction.
lava flows from the Pacific Ocean to the Mississippi?
It's not just lava flows.
Ashfall, gigantic rocks coming down. Right.
Yes. So the area of massive carnage and destruction is essentially.
And don't forget about the terrible loss of human life.
And the terrible loss of human life.
Yep.
If people don't evacuate, I'm all for evacuating.
Right. Well, we're going to talk about
firm
that
believer
in a second.
in evacuating.
Yep.
So yeah, from the Mississippi to the Pacific Ocean.
Right. Okay. That is a very large. I mean, that hits you and it hits me, and we are thousands of kilometers apart. Yeah.
Yes.
How? Okay, great. So, how much warning do we get?
We don't know. and so this is one of those things that we're currently dealing with, because one of the other famous massive supervolcanoes, in this case, we're looking at the other kind of volcano, one that's caused by a subduction zone. This is where you have one plate of the Earth plunging under another plate of the Earth. Things melt, things come up, literally. And in this case, there is and I'm going to pronounce this horribly because this is what I do on this show. It's the Campanium ignimbrite. It's generally listed as the CI caldera just about everywhere that I was reading today. This is the one that's under Naples and associated with the Philium Fields and all of these things that you read about in books. And if you're me, you haven't heard enough people pronounce out loud. And it turns out that last time this particular caldera decided to give up its magma to the atmosphere, it might have been the turning point in Neanderthal civilization.
Right. The timing is such that the Neanderthals. Okay, so let's talk a bit about just the devastation. You've got this volcano going in, be it Europe, be it Yellowstone. I think the biggest one is in Asia, like maybe I think it's in Indonesia. Anyway, this thing goes off. We already talked about the size. You're looking at thousands of kilometers across as a place where bad things happen. What kinds of bad things happen?
So locally, what you're looking at is it looks like these volcanic eruptions can occur in different phases, just like other volcanic eruptions at more normal scales do, where you have the oozing stage where there's a great amount of stuff coming out, but it's just hot lava sliding down the side of a mountain at melted rock kind of speeds.
Pouring into the environment, turning what was once a lovely national park into a parking lot.
Yes, that would be exactly true.
And you could run away from it at running speed.
Yeah, jeeps, cheetahs, all these kinds of things are useful. But then you're also looking at things like the pyroclastic flows. So, for instance, if you have water involved, if you have ice involved, you can end up with sudden, extremely high speed liquid magma, breccia, all of this sort of stuff flowing at high speeds. This is the stuff you can't outrun.
And like, talk about speeds, because the speeds are stunning. That you get this mixture of rock and water and gases and dust, and the pyroclastic. I mean, you say you can't outrun the pyroclastic flow. That is an understatement. They are going, like, how fast are we talking about here?
So some of these things have been clocked at like 700 kilometers per hour. That's 450 miles per hour.
Yeah, so it's like going almost the speed of sound from the explosion. Like, there's no getting away from this.
No. This is the you die stage. It is simply the you die stage.
Right.
So yeah.
Okay, you got slow oozing lava, no problem. I mean, at a scale you can scarcely comprehend. You've got pyroclastic flows that are flowing, away for quite a ways, right? Then so then we're looking at how does it end its life. We have the puffing large amounts of ash into the atmosphere that can go on. We have continued lava coming out. And exactly how these things go through their phases, we luckily haven't seen it happen in real time. But from looking at the way material has been laid out, let's go back to that Naples caldera again. Mm-hmm. It was estimated that in its eruption 39,000 years ago, that, there was up to 2 centimeters, 5 centimeters of ash all the way into central Russia deposited. Right.
And if you do that onto growing crops, they don't do so well. So in the area right around the volcano, so here we're looking at like the width of Italy, there was about half a meter of ash. And ash is harder to shovel than snow.
Yes.
there was
Yeah, and it doesn't melt, right?
no.
Yeah.
There was
We had the ash. Sorry, during Mount St. Helens, we got
yeah.
some of the ash up here on Vancouver Island and in Vancouver, and it was awful. It was like this. It was like this light for us. It was this light dusting, but then for other people, it just got worse and worse. And I actually have some of the stuff here. I don't know if people could see here. I'm gonna. Well, behind me, podcast listeners can't see it, but people who are viewing can see right beside my telescope. I've got a little jar there, and that's filled with Mount St. Helens ash. And I've actually got some chunks of pumice inside, and they actually float,
Cool.
which is cool. So we have friends that live down in the affected area, and they gathered some of the stuff up because it was everywhere, and like. You could do anything with
Yeah.
it. Yeah, it was a disaster, but very fertile.
So, uh, with the last time our CI supervolcano down in the Naples area went off, there was as much as 10 centimeters of ash, basically covering the Fertile Crescent. So all
Right.
all of Italy south of Naples, Greece was covered. All of the Fertile Crescent, northern Africa. Yeah. So a large swath of the planet, at least what was the particularly interesting part of the planet at the time, covered in ash.
Covered in ash, so everything dies. And now, but fortunately, those of us, around the world, nowhere near the affected zone, we're fine, right?
No. Sorry. This is
I know.
such cool science. I can't help but giggle. I'm not a fan of death and destruction.
I know.
I think
and
this
that's
is so cool.
Don't worry. I already disclaimed you at the beginning of this episode that you were going to get like giggly about a significant geological event, unrivaled in in power and destructiveness, and you are deeply aware of the depth of human suffering that would be caused by such a thing. So you can feel free to get silly about this and know that all those deaths would weigh heavy on your conscience. Please continue.
Okay. So I mentioned that the CI eruption 39,000 years ago probably did really bad things to the culture of the Neanderthals. The Siberian traps, when they last went off 252 million years ago, that was kind of about when the Permian Triassic extinction occurred. And this was one of those extinctions that killed everything.
Yeah.
Everything.
Didn't matter if you were on the land, didn't matter if you were on the water. 99% of all life, or 90% of all life, just died.
Yes.
Yeah.
Yes. And what we're looking at is a whole lot of different problems. You have locally, you're failing to outrun the pyroclastic. You are watching your city get buried in lava. You are then watching ash fall in hundreds, thousands of kilometers around the volcano.
Blocks of rock, volcanic blocks are just raining down, the size of a house.
Yeah, but let's look at what's happening above that volcano. So there's a volcano going off today. There's almost always volcanoes going off. There's usually more than one volcano going off. But the one that's being particularly interesting today is the Bogoslav volcano. And according to the Center Weather Service Unit, a pilot has estimated that this particular Alaskan volcano is shooting ash 38,000 feet into the air. This is well above the height that your typical transoceanic flight is flying at.
Right, they have to go above it.
Yeah. And they can't. So this is the kind of ash you simply go around because you can't go over.
And if it gets in your engines,
it shreds your plane.
Yeah. So just imagine the Neanderthals the terrible destruction they had on their airplane engines.
So beyond what it does to aircraft engines, all of this dark, light absorbing material getting tossed up into the atmosphere at like 10 to the 15 kilograms worth of this stuff, it kind of changes the climate. It kind of causes ice ages and glaciation, and well, climate change goes in a very different direction when these things happen.
Right.
So we're looking at changing the planet's climate for a significant chunk of time, which I'm kind of a fan of getting a giant, more Pinatubo or Krakatoa-sized eruption going off somewhere that would hopefully not kill anyone, with sufficient warning that we evacuate whatever island is about to blow.
What are the fun volcanoes?
One of the fun volcanoes.
Yeah, the ones that go off in a place that nobody lives and does no long-lasting destruction to the environment, and really, it's just really great pictures, and you can see all the cool lightning strikes going on in the, in the clouds. That's great. Sure, that's what you would hope for.
So when Pinatubo went off, it did cause some measurable temperature differences. Yeah. It caused significantly different color sunsets. And now, admittedly, Krakatoa and Pinatubo did kill large numbers of people, but we're getting better at evacuating islands. Yep. We really are.
Yeah, and did a pretty good job of evacuating Mount St. Helens.
Yes. There it was the stalwart individuals who were like, no, I won't die. I'm going to stay here. Yeah. So that's Darwinism. What we're talking about is like when you see... with a lot of the Indonesian islands, when the volcano alerts go off, they will actually like evacuate an entire island. Luckily, volcanoes like to rumble a lot before they burst. So as long as we get this kind of warning, and it's one of the remote places. Now, the issue is that, like I said, Yellowstone, if it went off the way it has in the worst cases in the past, that's everything from the Mississippi to the ocean.
Yeah.
So that's like Los Angeles, San Francisco, San Diego, Seattle, Portland, Denver. Yeah, I'm going to stop there.
Yeah.
I don't think we can evacuate that.
No.
Naples is actually a whole lot worse, because now you're looking at a whole lot of places where you can't actually drive to escape, because there's all of those Greek islands and Italian islands and owned by other people's islands that it takes a boat, and there's only so many boats. So yeah, supervolcanoes tend to be nice, interesting to live places that tend to be rather well populated at the moment. But you did bring up Tobo, which is one of the other massive supervolcanoes.
Yeah, the one in Indonesia. The one that created the lake within a lake within. Have you seen this? This is the lake within a...
Yeah, it's an amazing photo.
It's an island within a... It's an island on a lake, in an island, in a lake, in an island. Maybe one more of those. But... yeah.
And this is one of the ones that quite often gets misidentified as being an asteroid impact kind of crater, because it looks so asteroid impact-y cratery. But no, this is known for catastrophic eruption theory. Volcanic winter lasting 6 to 10 years and a 1,000-year cooling episode.
Entirely possible to have, for this to be the causes of ice ages.
This, in fact, people are doing more and more to link, as we're understanding our planet better, as we're going through and measuring the different radioisotopes in these different lava fields, basalts. As we're going through and working to figure this stuff out, we're realizing the timing alignment with a lot of these things seems to link either asteroid/comet impacts or massive volcanic eruptions, or both, to many of the extinction events. And you and I actually did an episode on this a while back.
So when was the last supervolcano to go off?
So the last, here we're going to have massive watch things die off, was the Naples one 39,000 years ago, but there's been ones more recent in parts of the world that are new enough they weren't particularly populated, like New Zealand. New Zealand is one of the biggest landable giant, it's not a tiny island. These are two fairly significant islands, and they're still being formed. It's really creepy when you visit New Zealand. Around Wellington, there's a highway along the ocean, and my driver took the time to let me know that the road had only been there for 300,000 years, and not 300,000, for 300 years. And there was like historical records of when that part of the land rose up out of the sea.
Right. Like a road was only possible there for the last 300 years or so.
Yeah. So the most recent category 8 was 26.5 thousand years ago in New Zealand. Part of making New Zealand, as you do.
I don't know. Every 26,000 years. I like those odds.
Now, the category 7 ones occur quite a good deal more recently. So looking in Indonesia, Mount Tambora went off about 135 years ago. So now we're starting to get at things only slightly older than the oldest humans. Again, in Indonesia, about 700 years ago, there was Mount Rinjani. So this is part of the reason that Indonesia is so good at evacuating islands. They have a history. But these things aren't dead. And we tend to get very lackadaisical about, oh, that volcano is dormant.
Yeah.
The Three Sisters complex in Oregon, one is extinct, one is dormant, one is still probably pretty active and could blow. And we don't talk about these things. And what's amusing is I just noticed the person who was driving me in New Zealand, Citizen Gold, is online right now. He's the one that told me about the road forming 300 years ago.
That's awesome. So I guess where I want to go in the end here is like, how can we know this is happening? What will be some of the warning signs, and when we'll know that it's time to bug out?
So GPS is your friend. Use it at all times to measure small motions in the surface of the planet. So what they do, places like Yellowstone, is they deploy sensors kind of all over the place that are measuring the expansion of the planet, changes in the tilt of the surface, changes in the altitude of the surface, changes in the north, south, east, west position of the surface. And all of these things can be used to measure how the planet is bulging. Then there's also just keeping constant track of, where are there hot springs? Oh, by golly, are we getting a whole lot more of these suddenly? Is there steam starting to come out of the surface of the planet? Let's quickly measure the gases and make sure that it is steam and not other gases coming out of the surface. One of the things that really got me is I was able to visit Delphi a few years ago, and the Oracle of Delphi was actually some poor set of women that were getting gassed by the planet, which was emitting toxic fumes, because Greece and Italy are basically very volcanically active.
Yeah.
So our planet gives off bad gas.
Right. But I fear that we may have panicked and frightened people. So can we bring it all home here? As we mentioned, this the last time a major supervolcano went off, it's 26,000 years ago in a largely uninhabited location. your chances of this happening is very low. So
no, don't say that.
Focus on your health. Don't smoke. Eat good food and don't drink and drive.
So I do want to say that that's false statistics, all because it's been 36,000, 24,000.
I know.
We have to look at what is the frequency of these things occurring. And now, is one going to go off tomorrow? Probably not, but it could.
Mm-hmm. Yeah, and one could go off every day for the next, until we run out of supervolcanoes, right? Absolutely. That's the way statistics work. We did a whole show on this.
But I think the lesson is live fully, live completely. No, we could all die tomorrow, but we probably won't.
Right. We probably won't. So don't use any of this as an excuse not to brush your teeth.
Exactly.
All right. Well, thanks, Pamela. I have no idea if we're going to continue this series. I'm having fun. Clearly, you had fun. We'll talk to you next week.
Sounds good. Talk to you later, Fraser. And now we save.
Did you hear the dog?
Yes. The dog agreed.
Yeah. Dog was yawning. Dog's got ants in her pants right now. Okay.
We should do something on symmetry for 444.
Oh, sure.
Just thinking.
Mm-hmm.
Have we done something on fractals yet?
Nope. Okay. And then I'm going to upload this to the Dropbox.
Yep.
I've decided to never use... I think a bad child left my front door open. 1 second.
And while Fraser goes to see if the OA has left his front door open.
All kids are good. All right.
Okay.
Now is the time when we talk about your questions about space and astronomy. So let's roll. Chocolate Wish, I feel panicked and frightened. Fraser, hold me. Oh. From Titus Verdius. Can JWST detect a supervolcano eruption on an alien planet?
It depends on what it does to its atmosphere. I mean, if we measure a planet's atmosphere and it looks one way, and then a little bit later we look at its atmosphere again, and it's like, holy expletive, Batman, that looks like it's filled with volcanic silicas and stuff like that. So the only way you could really do it is as a change in an atmosphere.
Right.
And I honestly don't know if James Webb has the capacity to measure the needed changes or the kinds of spectral indicators that we'd need to measure.
Right. I mean, I guess it would be a matter of like, once you can detect the atmosphere of another planet, are you detecting sulfur dioxide in the atmosphere? If so, that's an indication. But
to know that it's a single event like a supervolcano or something like that, I mean, it could just be like a planet like Io that is just going to keep exploding forever, because that's what you do if you're Io. Yeah, so it's really looking for that change in atmosphere that gives you the individual.
From Arjun, are most of the supervolcanoes in the northern hemisphere? I don't think that's true.
No, those are just the ones I chose. Well, Indonesia kind of spans hemispheres. So looking for the handy dandy map, I know there's a bunch of known massive events in Chile and Argentina all along that ridge. Indonesia is kind of coded, New Zealand, which I mentioned, Japan, Siberia, and then, North America.
So, from William Van de Beek, how do you know the difference between a supervolcano and a historic asteroid impact? Can an asteroid punch a hole in the Earth's crust and create a new supervolcano?
I don't know on the second part.
Right. We'll talk about that in a second because there's some pretty interesting research there. But
Yeah.
how do you tell the
But
difference between an asteroid impact and
it's so an asteroid impact is going to leave a layer of iridium all over the planet. It's one of those things that comes quite frequently from space, but isn't natively here. Whereas a supervolcano going off is going to leave like normal earthy stuff everywhere in a layer of gruesome basalt.
Right. I mean, it's just like, are there earthquakes going on? Are there, is the ground moving around? Is there sulfuric vents and geysers and hot springs? And like a volcano is an active place, right? While an asteroid impact is just a wreck. It's just a place where something smashed in, and now you just got just rubble. And so it's not like it's active in that way that a volcano is. But we talked a bit about that big asteroid. Could it punch a hole in the Earth's crust and create a new supervolcano? But one of the ideas, as I recall, for the Deccan traps is that it's at the antipode on the Earth from where a big asteroid struck the Earth. And so you actually got this, like, the waves, when the asteroid smashed into the Earth, the waves went all the way around the Earth and collapsed or sort of bunched up on the exact opposite side of the Earth and potentially formed the Deccan traps.
Exactly.
Which is crazy.
And there used to be, but I don't see people... There used to be people theorizing that hotspots like the Hawaiian Islands might have been caused by that bullet of an asteroid. But nowadays, the general consensus is that it is just like a normal everyday magma plume. Still don't know why we have magma plumes in the places that we have them, but it's still
like we don't know why the Hawaiian Islands are a hotspot there.
Yeah. Why there and not New England?
Richard Strassel asks, how long would an eruption last? Kaboom, right? It would just be like would it be like one of those volcanoes that's spraying lava for a couple of weeks, the way some of the ones like the unpronounceable Icelandic one, or the one that's happening up in Alaska, or would it just be like one big kablooey and then that's that?
So the last time the Naples supervolcano went off, they estimate that the Flinian phase, this is the fairly normal, nice, happy eruption stage, probably went on for 2 to 4 days. There was an ash plume that reached a height they're estimating of 43 miles, so pretty high. And this eventually led to the pyroclastic flows, and it wasn't an instantaneous event. It spread out over days. And if you think back to when we've watched in recent years the Icelandic volcanoes go off, you have everything from one giant burp that lasts less than a day to I'm going to sit here and be explosive and ruin traffic, air traffic for a couple of weeks. It takes however long it takes.
Yeah. But the point is, like, it's not going to be erupting for years. You're looking at a couple of days, and in that first day, it's going to be a very vigorous event. I mean, we think about Mount St. Helens, right? Like Mount St. Helens began and ended in a couple of hours.
Yeah.
Right? It was just and the whole side of the volcano, the whole side of the mountain just blasted off, slid down down the side and filled the river with ash and the pyroclastic flows, and then that was that, right?
Yeah, and it really is hard to predict because volcanoes do what they decide they're going to do. And it has to do with where are what stresses and strains on the crust of the earth allowed? Where is the pressure? Is it symmetric? Is it asymmetric? Is it something that has a lot of gases in it? Is it something where the chemical composition changes throughout the eruption period? So many different variables go into it.
That's Willis in the chat. I have a t-shirt which has how to pronounce the unpronounceable Icelandic volcano written out phonetically, which is awesome. So, hey, plots. Go plots. Good dog. One of our dogs speaks German and one of our dogs speaks English. So,
which allows you to control them one at a time.
One at a time, that's right, yeah. So I can make one dog bark by saying "Geeblouts," and I can make the other dog bark by saying "speak." Yeah, it's pretty funny. It doesn't work though. They're both bilingual, which is pretty funny. So they both understand each other's, especially you want a treat, things like that. They totally understand that. Let's see. So Francisco Alves, what would be worse, the pyroclastic wave or the new ice age? Both. I mean, depends where you live, right?
The pyroclastic flow gives you no choice. The ice age, you have the ability to build the technology to survive.
Yeah. Okay, so Nancy wanted to know, aside from the fact that lunar soil is razor sharp, how does the consistency of volcanic ash compare with lunar soil?
So the Mare region on the moon is not significantly different from lava flows here on the Earth, and there's awesome comparative volcanology people that will go, here's the volcano on Earth, here's the volcano on the moon, here's the volcano on Mars. Let's look at how all of these things are identical. It's cool.
Yeah. I mean, it's like, anyway, yeah. The ash on the moon is part of its problem is that it's pounded by the micrometeorite impacts into this glass, right?
And volcanic earth
more like a grit.
No, they're both glass. It's a scale size difference. So here on Earth, where we have a big old chunk of lava, it's not getting constantly pummeled by micrometeorites because our atmosphere eats those. So it sits there going, hi, I'm a rock. Mm-hmm. And when it gets broken up into sand, it's getting broken up into sand by erosion processes that round the edges. So volcanic sand, while sharper than a lot of other sand, is still rounded sand.
Right.
The regolith on the moon, it's you've sledgehammered it and not rounded it in any way.
But it's the difference. Dust is bad news to breathe on Earth too, right?
Oh yeah, because it also isn't rounded. It's just explodey bits that cooled into the air.
Titus Viridius wants to know when I'm doing another collaboration with Isaac Arthur. He's actually got an open invite to join us on the Weekly Space Hangout, which is going to be great. So at some point, and then anytime he wants, man, that was super fun. We did a 2-part episode on colonizing the solar system. I took the inner planets, he took the outer planets, and it was a lot of fun. So if you haven't already followed Isaac Arthur's channel on YouTube, he is he's just phenomenal. The topics that he just covers are so great. Just totally scratches. Like if you enjoy some of the really out there stuff that we talk about here, check out his channel on YouTube. He goes way out there, about like what would first contact really be like, or what are the comprehensive explanations for the Fermi paradox and things like that, superintelligence, AIs, and the singularity and everything like that. So I highly, highly, highly recommend you check out Isaac Arthur's YouTube channel. And I'd love to work with him some more. The problem I have with him and with a bunch of these people is is that I can't watch their shows, because then it infects my brain, and then it clouds my thinking. And so I'm like, I need to come at this stuff from my own kind of original direction. And the problem is that then I read, then his ideas are so good, they get into my head, and then I'm just like a puppet for Isaac Arthur. So I can't do that. I gotta remain. And so after I finish the topic, then I'll go back and watch and see what he did, and go, oh, he did it so much better. So but hopefully if we can get him on camera, that's the key. He's just a disembodied voice, but I want to get him on the camera and be in the chat and have him hang out with us. So question.
So everyone out there, go ahead, join the Weekly Space Hangout crew. The information should appear in the chat below us in a moment. And this is your way to get a backdoor to the two of us, where you can propose shows, you can ask us questions. We periodically go in and poke and ask our own questions to get feedback on what we should be doing differently.
Yep.
So join the Weekly Space Hangout crew and see what happens behind the scenes.
We often take our topics from all kinds of sources, right? But it's all sort of timing. Have we already got a bunch of topics planned out and then we're just running through them? Or are we desperate for an episode and some fantastic idea rolls across our screens and we jump on it immediately and make that the episode? So, but absolutely, we love to have your suggestions. Is Isaac a confirmed guest? I guess. I mean, I said, do you want to come on the Space Hangout? And he said, yes, I do. And then I said, when? And he said, I don't know, I'm really busy. And I said, okay, great. Well, you just tell me when you're ready. And that's where we stand. So that's as confirmed as things get. We've got some other super cool confirmed guests coming up. We've got they're not in the schedule yet, but who have we got coming up? David Grinspoon has agreed to come on. Yeah. We've got Alan Stern, of course. He was supposed to be with us, but he wasn't able to. Your favorite Lawrence Krauss is going to be coming on an episode, which would be great at some point. He's got a new book out. That's my trick, is that if you've got a book out and then you're looking to promote your book, then come on to the Weekly Space Hangout and let's tell us all about it. Dr. Michu Kaku, sure. If he wants to come on the Weekly Space Hangout, I would be glad to interview him. Let's see. Okay, well, I think we're done.
So,
go ahead.
Sounds good.
Say the thing. I was
just gonna say, to join the Weekly Space Hangout crew, go to wshcrew.space.
That's right, with the new .space domain. Francisco Alvarez, since we're name dropping, I want Neil deGrasse Tyson. Of course you do. Of course we all do. And every time Neil deGrasse Tyson releases a new book, I invite him on the show, which is as I said, that's the easy way to get people. But at some point, I'm sure we will. Dane is saying it would be awesome to have a collaboration between Star Talk and Astronomy Cast. We've helped each other out in the past.
Yeah.
So they did a live show at one point, and we did some technical support. Pamela, of course, in the Shush Heard Round the World, is on stage shushing Neil deGrasse Tyson and Lawrence Krauss, which is awesome. I don't know what the title of that is. So,
if you just Google all of our names, it was at the amazing meeting a number
Pamela
of years ago.
Neil deGrasse Tyson, you can see that. Alan Stern is going to be here in a couple of weeks. I forget the exact date, but he'll be here to talk about New Horizons on the Weekly Space Hangout. Not here, over there on the Weekly Space Hangout. All right. So let's wrap things up. So thanks, Pamela. Thanks, everyone, for watching. If you haven't already, join the Weekly Space Hangout crew. Give this video a thumbs up. I like it, and we will talk to you next week. Yep. See you later.